All right, everybody, we're live, and hopefully you're being very good and respectful, because if you're not, I'll get even with you, okay? So today, our objective, today's date is 11/5/19. Our objective is really going to be reducing, multiplying, and dividing. We're not going to say fractions. We're going to use the math word, reducing, multiplying, dividing, rational expressions. Okay? So we've learned that the term rational means fraction. But in here it's not just simple fractions, it's fractions with x's in the denominator. Okay? So, two things. First of all, we don't ever want to divide by 0. So we're going to take a look throughout the lesson, and before we do anything, we've got to talk about what x cannot be. And the second thing I want to do is this. I want you to see a little side note. Okay? If I have 7 plus 3 over 7 minus 5. Okay? Go ahead and just watch. You don't even have to write this down. Just watch. You cannot cancel 7s. You can't. You can't. The answer is not 3 over negative 5. In fact, we know this is like parentheses. Even though we don't draw the parentheses, it's really like parentheses and parentheses. So the parentheses are kind of invisible. So it really is 10 over 2, which is 5. It is not 3 over negative 5 at all. So the reason I say that is when we get to example 1, don't cancel the x squareds. Don't. It doesn't work that way. You need to be able to add everything. Don't cancel the x's. You can't do that, right? It does not work that way. So, before we do anything, we just got done doing a whole review on factoring. So, most of what we're going to do today really depends on whether or not you can factor. And if you can't factor, I'm really sorry, but you got to be able to factor to do this. And if you can't, then you get better practice, okay? So, let's take a look at example 1. We know, first of all, that you can't divide by 0. So let's look at the denominator. But I'm going to factor. So I'm going to factor number 1. The numerator is going to be an x plus 3, x minus 2, and the denominator is going to be an x plus 4, x minus 2. Okay? I just factored the denominator and the numerator. Numerator is the top. So I don't care about the top. The top of the fraction, 0 is okay. 0 on the top is 0. 0 over anything is 0. 0 divided by 5 is 0. There's nothing wrong with that. But if you try and go 5 divided by 0, you're going to have a problem. You cannot divide by 0. So in our case, we just have to look at the denominator. So in this case, what we know is that x cannot equal negative 4, because negative 4 plus 4 is 0. And x cannot equal 2. Those are going to be the excluded values of x because they don't exist. So now, the domain. Domain is everything. Everything, every possible number you can think of except these two. So my domain is going to be x equals everything, all real numbers, except x cannot equal negative 4 and x cannot equal 2. Okay? Now, anytime you guys need to pause this video, please ask, and the substitute will pause it for you, okay? All right, number 2. Now remember, we want to factor as much as we can. Before I do anything, though, I know that x cannot equal 0, because 6 times 0 squared is 0, so x cannot be 0. Now, let's factor. Well, I'm going to common factor out a 2x squared from the numerator. They both have a common multiple of 2. And they both have an x squared in common. So if I common factor at 2x squared, I'll have an x minus 4 over my 6x squared. Now I can cancel the x squared because it's a multiplication process. So then x squared cancels x squared. 2 reduces to 6, reduces to 1/3. And the answer I'm looking at is 1/3 of my x minus 4. And I'll put the fraction line all the way across. Okay? Example 3. Again, excluded values. Let's look at excluded values. So let's factor first. Okay, I'm going to factor. So if I factor this, I'm going to rewrite this as an x minus 4 and an x minus 1. Multiples of 4 that add up to negative 5. And I'm going to factor this into an x minus 1 and another x minus 1. Okay? Now, the 0 on the top is okay. I don't care about values on the top. But on the bottom, I really do care. So x cannot equal 1 and x cannot equal 1 again. So we get the same excluded value. Okay, so if I'm simplifying this though, wait a minute, I can reduce this. There's more I can do. I can reduce. So if I go and reduce my x minus 1, then my reduced fraction is an x minus 4 over an x minus 1. I just reduced my fractions. Just like I reduced regular fractions that I learned in 6th grade, I'm just reducing fractions. But this is different because it's with rational expressions. Okay, I'm going to turn the page. Okay, example 4. So when I multiply, and you guys saw in the warm-up, when you multiply two fractions, you can sometimes cross-simplify. But before I do anything, we have to factor. Again, if you can't factor, I'm so sorry for you. I feel so bad for you, but you got to know how to factor. So let's factor the first fraction. Factor the first fraction. So the numerator is an x minus 3 times an x plus 1. And the denominator factors into an x plus 1, x minus 1. Okay? Let's factor the second fraction. So if I factor the second fraction, I will factor it into a x minus 9 and an x plus 7, because 9 times 7 makes 63, but a negative 9 and a positive 7 makes a negative 2. And for the second fraction, its denominator is an x plus 7 and an x minus 3, because 7 times negative 3 is a negative 21, but 7 times negative 3 is also a positive 4x. Now, we're going to reduce. I'm going to cross-simplify, like you guys saw in the warm-up. I can cross-simplify. So anything on the top can cancel with anything on the bottom as long as it's the same. So if I look, x minus 3 will cancel x minus 3. Okay? X plus 7 with an x plus 7. Okay? That's gone. And then finally, I got an x plus 1 over an x plus 1. So everything has been canceled. Don't cancel the x's here and here because it's an x minus 9. But what I'm left with is a very reduced answer, x minus 9 over x minus 1. And that's my answer after I multiply. So it's kind of handy because I have this big, ugly problem and I make it look much nicer, okay? All right. Last problem. And again, if I'm going too fast, you want the substitute to pause it, go right ahead. Okay, now, example 5. Well, let's see. Let's do this first. Everybody watching? See that division sign? So before I do anything, I'm going to flip the second fraction. I'm going to flip this. So let me rewrite this. Everybody, you have to do that. When you divide fractions, you invert and multiply. Or we flip it. So let's rewrite this. X squared plus 2x minus 15 over x squared minus 3x minus 40. So I'm going to rewrite the first fraction. But now when I write and rewrite the second fraction, I'm going to flip the second fraction. So I'm going to go times. We invert and multiply, right? X squared plus x minus 72 over x squared plus 8x minus 9. So I inverted and multiplied. You guys learned that in 6th grade, and we did that in our warm-up as well. Okay, now, factor. I know it seemed really easy just to cancel x squares, but it does not work that way. Remember we talked about that over here? You can't factor, you can't cancel that way because it really is, the parentheses are in their sense there. Okay, so let's factor. I can do that. So, let's take the first fraction. The numerator is x plus 5, x minus 3. The denominator, let's see, 40's got to be probably 5 and 8. So I'm going to go x minus 8 and x plus 5 times, because I changed it from division to multiply. Let's see, 72, how about 8 and 9, x plus 9 x minus 8, because there's a 1 right there. And then on the denominator of the second fraction, we're going to have an x plus 9 and an x minus 1. 9 times negative 1 is negative 9, and when I add them I get a positive 8. Okay, now here comes the fun part. This part I like to do. I like to cancel. So let's see, what can I cancel? Let's see, x plus 9 and x plus 9. Anything on the top with anything on the bottom, okay? And let's see, I've also got an x minus 8 with an x minus 8, okay? Anything on the top with anything on the bottom, okay? X plus 5 over x plus 5. So finally I can't cancel anything else. I'm left with an x minus 3 over an x minus 1. Now isn't that a nicer looking answer than the original problem? So the original problem is pretty cumbersome, but this is a nice little answer because everything reduces just like fractions reduce. Okay, that's all I have. You need to do your homework.